My name is Abel Cortinas, and I work in the laboratory of Daniel Anderson here in the Koch Institute. And one of the things that my lab does is try to develop new systems and therapeutics to treat diabetes. The subset of diabetes that my research focuses on is known as insulin dependence diabetes, where the body does not produce the insulin required or necessary to offset the blood sugar changes that the body encounters with everyday life. Insulin is a protein produced by the pancreas that is responsible for lowering blood sugar in the body. Insulin works well. It does a good job at lowering blood sugar, but it's having to be that system of checking your own blood sugar, of figuring out what dose you have to inject, injecting that dose, waiting. Did I inject too much? If I did, eat sugar. Did I inject too little? Okay, I have to inject more insulin. And it's that feedback loop that ends up being the burden of the individual as opposed to the burden of the pancreas. So one of the biggest issues with using insulin as a therapy for diabetes is that it is a type of molecule that can be very dangerous and very lethal if you use too much of it. And if you inject yourself with too much insulin, you could go into something known as a hypoglycemic shock, where your blood sugar becomes dangerously low. So in my work, I focus on trying to engineer the insulin protein. One of the issues that my research tries to tackle is the ability to have this switch on insulin that can turn itself on when it's needed, but also more importantly, turn itself off when it's not. So my image involves the overlapping of two separate images onto each other. The first image is taken with a standard light microscope of protein crystals of our smart insulins, which are shown as cubes. What you see are effectively protein molecules that have been introduced at a high enough concentration where they crystallize. In the very similar nature, if you were to grow rock candy in a jar of really saturated sugar water. The other image, which is overlapped, which you see as grid lines with patterned dots, are the data that I get from shooting these crystals with X-rays in an experiment known as X-ray diffraction. And so by shooting crystals like the ones shown with X-ray beams, we can gather a really important information about the three-dimensional structure of the protein, which can help inform us and help us lead to developing better versions of these smart insulins that we are trying to tackle and trying to develop in the lab. I have a history of diabetes in my family as well, and I've seen the toll that it can take on people that I care a lot about. And so to be able to try and help relieve some of that burden in any way that I can is one of the biggest motivations.
Oh my goodness, I'm so
wow.
sorry. Square in there.
Interdisciplinary work, oh no.